Eli, your team's 3.
Yeah.
We're team 2.
2.
I'm 1.
Okay, we have the other number, whatever. I
You guys
don't
have
care.
4.
4.
2.
What the shucky darn, bro?
Did you say shucky darn?
What else am I supposed to say?
Bro, get out!
Can we start?
Yep.
Can I open the door?
Yep.
I've had enough, guys. Be professionals. Get out!
Yeah. Oh. Bye. Bye, Amy. This is our skill model challenge. My name's Haley. My name's Natalie. We use Tinkercad for our technology. Our launcher is a skill model challenge, and this is our project being ready to print. Make it work.
I think you're
I don't think it works.
Pull that red cord out and plug it back in.
Like
From the wall.
From Stop.
Do not just yank it, there is a lever. Pinch it.
A lever?
And pull. Pinch.
Oh, sorry.
Boo!
Boo!
Great. Can you plug it back in?
Yeah, I know. Restart. Restart it.
Nope. Yeah. Alright, I guess I'm just clicking today.
Smart goal. Our challenge is to demonstrate our ability to work with exponents and represent a real-world object at a different scale. Your challenge is to create a CL model of an existing object using Tinkercad. Our SMART goal. We will use the Tinkercad program to complete our scale model challenge of the Mackinac Bridge using block shapes. In these 4 days, we will be able to complete a model that is scaled for every 100 feet equals a half of it. We have all the resources needed to do this project, which includes Tinkercad and the internet. We are building this because we're familiar with the bridge. We plan to reach our goal by day 3, possibly part of day 4. On day 1, we will start scaling and planning the building process. Day 2 will be finishing the design process, then start the building process. Day 3, we will finish the building part of the bridge. Finally, day 4, we will be done and move on to the next part of the project. Woo, worked. About our technology. Tinkercad is a website that you can use to make anything you want, including 3D scale models. It's highlighted because that's one of our vocab words. It is a free. It's a free app. It's a free app, and it has many things to do to explore on the app. And this is just exploring your different tools of shapes in Tinkercad. Relating our launch to the real world. This is the real Mackinac Bridge, by Michigan. That's our special Mackinac Bridge. Tinkercad is used to make 3D models of almost anything you want. Tinkercad uses a simplified constructive solid geometry method of constructing models. A design is made with whole solid shapes, or there's an option for the like whole pieces. When you combine solids and the whole pieces together, you can create new shapes. It gives you the option to test your design in the sim lab where it simulates gravity. Tinkercad offers extra features that are multi-board simulation and complex analog circuits for experienced users. What problems did we have? We had problems trying to figure out how to group the shapes together. We also couldn't find out how to downsize it, but we found a tutorial and asked questions, and this is the tutorial of how to group. What did we learn? We learned how to use squared roots and cubed roots to demonstrate how to calculate dimensions and scaling a model larger or smaller. We also learned how to group, duplicate, and repeat objects. So for our bonus points, because we had to learn something new in Tinkercad, we found out that you can change the colors. I actually didn't know you could do that. You could change the colors of your highlights. I thought it could only be the yellow and green. Yes. So, yep. What problems did we have? Oh, did we already do this? We did this one. Should have thrown backwards. Oh, there you go. Explore deck. For our first, we explored skill models, demonstrating properties without having an original model. Then you can show the dimensions and easily show how modified it is to models of an object to be used for designing processes. When it's proportional, there are similar sizes maintaining a constant ratio throughout different parts of the design. Scale models are typically small compared to prototypes. They show how they look and the size of the designs, while prototypes demonstrate functions. This is our launcher telling us what to do.
Day one. On day one, we worked on the dimensions and started designing the bridge. We learned that you have to scale the dimensions as the same size all the way around the shape. We used math, including perfect squares. We used it in how to figure out how small we needed a bridge to be in inches based off the dimensions of it in feet. We would have used different shapes for the side of the bridge if we had time to explore more. New question we had is why do we use shapes back to line together? And those are like shapes we use to build that bridge.
Day two. Oh my gosh! On day 2, we continued to build our bridge, and we got quite far. We learned how to duplicate and repeat and combine the shapes together. We used math while measuring where to place the correct pieces. We could have changed the sizing of our shapes. The question we had is how to connect the shapes together. This is us grouping together everything to complete our bridge.
Day 3, we completed our bridge. Then we scaled it down with the help of exponents to get it ready for it. We learned how to group objects together, and we used math when we had to scale it down. We kind of downsize it in an easier, simpler way, and that's our bridge.
Day 4. Today we finished grouping our stuff together and prepared to print our project. We learned how to put it together in the 3D printer app. Math was involved in how to scale it down to make it equivalent in the scale, but smaller to be able to print. If we had the resource, we would have made it bigger to print, but we didn't have a larger machine. The question we had is what would it look like if it looked like it used a different support design. And this is our overview of our bridge before putting it into the printing app.
And we didn't finish printing it because
Yeah, we didn't finish printing it because we just didn't really have time. And we didn't really care to, I guess.
Conclusion. Our challenge is to demonstrate our ability to work with the exponents and a real-world object at a different scale. Challenge is to create a scale model of an existing object using that. Oh, we achieved our SMART goal by completing our bridge with scaling. Yes, we would do it again because we found a German in it. We would change what project we did and how we scaled the object smaller. We liked that we could choose anything and have the resources to build it. We had success in modeling the Mackinac Bridge and being able to print it. Well, trying to. Something we learned is how to group and duplicate objects to make it easier to build. As partners, we work together amazingly. We split the work so we both can be involved.
Our vocab words, skill model challenge, modeling.
Just read that, don't read
Oh, do you don't want us to read it?
No, you don't have to read that.
Oh. Woo! Hey!
Boo!
Eli, I
Woo!
will add that after you get changed.
Let's go, guys.
Okay.
My first.
Alright,
Oh,
before-
I can't forget.
Add it.
Who's going next?
Number.
We still got number 3.
Oh, wait, what?
Oh.
We got number 3 still.
There's number 4. You have to do 1 through 4.
No, you guys are done. Now it's 1.
Because we'll take 1.
I'll take 3.
Yeah,
I'll
No,
take
we already
3.
have 3. You guys have 2.
So Kenzie's group has 2.
he had his hand up.
You guys have 2.
Let's go! I knew it.
Fudge nuggets.
Knew it too.
There you go, Cody.
Oh my gosh, I forgot to delete that page. Oops. Okay, we're just like.
Come on, guys.
Okay, this is Bridge Designer by Kinsey, and we used our Bridge Designer software, and then our launcher was Bridge Designer Bridge on a Budget.
Our challenge is to use Bridge Designer to engineer a cost-effective truss bridge that will support a two-lane highway across the river valley. Our SMART goal: we will use Bridge Designer software to create a bridge to support a two-lane highway across the lake of the river valley, then make it cost efficient by using our ideas to work together in these 4 days bridge designer software and our launcher to guide us through this design and help along the way. We are creating this because when looking through the launcher, this seemed the most interesting to both of us. On day one, we will start working on designing our bridge. Day two, we will work on improving our bridge and test it out. Day three, we will start reducing the costs of our bridge and adjusting to the needs of our city. And finally, on day four, we will make any less improvements and make sure our bridge works like we designed it.
About your technology. We use Bridge Designer 2016 version. It is designed to introduce students to engineering through a realistic hands-on design experience. It is also used to teach people how to be responsible. Many people may get confused because they think that they're just looking to make it cheap, but they forget about one of the most important factors, which is making your bridge sturdy.
You can use bridge to get across water. Bridges can also be used to connect cities and other things together. They are a faster route of transportation. You are basically cutting across instead of taking a longer route to get to the same place. Bridge designer helps relate to the real world by providing you with a realistic hands-on experience. Bridge designer is great for people that want to go into design. It gives a explanation on how to build it. If you do not have a sturdy design, it will tell you to fix it.
And then this is our bridge that supports a 2-lane road, and then this is our middle road. What problems did we have? We had problems when we would start a design because it would say we had squares. Bridge designer did not like squares in our designer. You could have triangles and other shapes, you just couldn't make it a square. We fixed this by making sure everything was a triangle before we tested it. We also had problems with getting our costs lower on our bridge. We tried multiple ways to lower it and nothing seemed to work in our favor. We changed this by changing some of our settings at the beginning before we started with our design. And this is what I would say when we had squares. It would like highlight it and say it was like unstable.
What did we learn? We learned a lot while doing this lesson. We already learned how to work our bridge designer software. We also learned how to design a bridge and lower the cost to make it responsible enough. Kinsey learned how to change the settings in bridge design to hopefully cover the cost of our designs. She also learned how to modify the cost and create a design she wanted. One most important factor is that we learned how to work together and
And this was like the settings that you could change at the beginning. It gave you a whole bunch of different options, and some like made it pricier and some made it cheaper. On day one, we brainstormed to figure out which designs we would want to do. We had multiple ideas, but we altered most of them because they wouldn't work. We tried many of our ideas to make the bridge pass, but they failed every time. What we could have done differently was kept trying to modify our bridge after it didn't work instead of redoing the whole thing over again. Another thing we could have done differently was to look at some ideas to help us improve our thinking. If we had to redo this day, we would definitely look at the ideas first and then put our thinking together to improve the bridge. And this was like our bridge on day one and day two.
on day two, the university explored and got our bridge design test to work on. This day we were working to lower the price of our bridge. Our design that they finished working on this day was around $350K. This was the day that we figured out that our software does not like squares in our design. We also learned that we needed to turn or off for our tests to load correctly. If we could have figured this out on our Explorer, maybe we could have been on the track with our results.
And then today we finished
finish the design that we were working on day 1. On day 3, we made improvements to our previous bridge. After we finished fixing what we wanted to fix, we made another design. We decided that we wanted to work separately and see if we could get them lower with our different designs. Kinsey got the bridge down to 310,000 and Brody got his down to 370,000. When they started those bridges without modifying, they were at around 700,000. Today we figured out that we could use the options on the first slide to help us lower the costs. And then this was, I think it was my bridge on day 3. Maybe it was yours.
On day 4, we both built other bridges. We tried to modify the cost. We used multiple structures and rods to see if that would change the price. This was the day that we learned when there is tension and compression, we should use hollow tubes. This day we both felt like we were both rushed to finish our projects because it was our last day to work. We rushed to finish up our project. Also, we used this day to figure out which bridge we wanted in our final products. We used these days to figure out if we should use thick or thin materials to lower our prices.
And then this was Brody's bridge on day 4. This was my finished product, and it was like around 290,000. And now on this Brody's one.
Yeah, only like $10.
Conclusion, our challenge is to use bridge designs to engineer a cost-effective truss bridge that will support a 2-lane highway across the river valley. We would both say that we reached our SMART goal. We would do this launcher again because we both enjoyed it. We would change how we learned to build bridges before we would start building. We would change the settings so that we don't have to change them after we already built the bridge. The thing we liked about this launcher is that it was pretty easy to work and we had our own freedom. We had many successes, one including that we both built multiple bridges. All of our bridges were successful after we figured out how to turn our exaggeration off. We learned that we could alter the settings at the start to lower the price of the bridge. We also learned that the bridges are more important than we thought. We'll say that we worked all right together. We mostly agreed on each other's decisions and didn't have much problems.
Okay, good. Huh? No.
And then our bonus was that's pretty fire.
No.
Two.
You said it first.
I said 2. I said 2.
Aiden called 1 before we even started.
Oh.
10.
Caden!
It is good.
Yes.
2K.
This is not your fault. Why are you just saying 2 games?
Robomaster S1. I'm Aiden.
Not a jury.
Robomaster S1, Tornado Rescues.
Again?
Our challenge is to program the Robomaster S1 to search for a person and alert when he or she is figured. You will draw a sketch of the area. The robot will search on a coordinate grid. To help you with your programming, you will describe different locations and compare distances by using the absolute value of the coordinates. Our SMART goal. We will use the Robomaster app to create a program to find someone by face recognition, and it will shoot them in the body. In these 4 days, we will be able to code it and have it be able to find someone and shoot them from a point in the different room than the original room. We will use the coding app to find the person with the Rollmaster, and we will have it be able to shoot them with the coded part. We are creating the code to find someone if they are trapped or in a confined room, and have it beat them or shoot them. Day one, we will start to code the Rollmaster and figure out what the code means. Day two, we will start to code the project and try it out. Day three, we will start the main project and we will make sure to code it right. Day four, we will be finishing coding on that day.
About our your technology. The Rollmaster technology is in Axis, which is important of the body. The gimbal for the camera and the blaster. The app is used to control the Rollmaster and code it, which is the main part of the launcher. The code allows the Rollmaster to get commands to shoot and make sound.
Later launcher in the real world. The launcher is used when there are disaster zones that are hard to reach and are dangerous to living things, and are provided valuable to search and rescue teams. They can also save people from flood areas, deliver supplies to those stranded in remote areas, and put out fire when conditions become too dire. They can also be UAVs, also known as drones, for search and rescue missions. There's our robot that will drive on coded. It is a real world robot that was from coded.
The problems we had were the lack of knowledge, the need to know what the blocks meant, and not knowing what the blocks needed. The other blocks to work, we solved the problems by learning how to code the way using the blocks to learn what we did, and I watched the video every time to know that we needed more than one block to move the gimbal. The mechanized stand to keep the camera horizontal.
FPGA slide.
What did you learn? We learned the meaning for the code blocks, how they work, and what they need to do things. For example, the yaw axis, you needed the free movement from the settings slide for it to move horizontally, which the pitch axis did not need it. The code of the Rollmaster was confusing because if you did not do it correctly, it would not work.
Just
Can you
what the omnidirectional wheels are used for, or that. The wheels are used for the movement of the Rollmaster. Omnidirectional wheels are the rollers, and the spot that holds them together, which allows them to move in any direction, and for endless movement for the Rollmaster, which allows it infinite movement, and so it can dodge in any direction.
What the chassis is used for? The chassis is the boundary of the Rollmaster, so it is the protection, and it holds the gimbal, and the wheels so that it can move and see where it is going. So it is important to have the chassis for the Rollmaster.
Still, what the people it's used for. The gimbal is the camera and where the blaster is held, so it is basically the eyes for the RoboMaster and the offense for the RoboMaster, which is important for the DIY programming part of the launcher. The gimbal is also how the camera on the RoboMaster is able to move in any direction.
What the intelligent controller is used for. The intelligent controller is how the RoboMaster gets commands so it can move, shoot, and get orders from the programming part of the app. And the is receiver of the RoboMaster.
What the pitch axis and yaw axis are. The pitch axis and the yaw axis are the ways the gimbal moves and the way the cases move. So it is why it moves horizontal and vertical, and that is why in the coding screen on the cases, the gimbal slide it shows the yaw and pitch axis.
The RoboMaster app. The RoboMaster app is used to code the RoboMaster and make it do things like drive it. You can code by dragging boxes that carry out the code. The app has different modes to choose from. You can play a battle mode and a solo mode. You can code it and go into the coding mode, and you can see what the RoboMaster is seeing. You can also enter the settings where you can change the speed and color of the RoboMaster.
Our challenge is to program the RoboMaster S1 to search for a person and alert when he or she is detected. You will draw a sketch of the area your RoboMaster will search on a coordinate grid to help you with your programming. You will describe different locations and compare distances by absolute value of coordinates. So our launcher outcome compared to the Smart Goal was a bit different. We could not code it to find someone, but we could only identify two classes and shoot diagonally. Yes, we would do this launcher again if we could and change the coded part of the RoboMaster. We like coding and driving it around in a room. The success we had was coding it and getting it to work. We learned that the lots of code means and with the code in blocks to make them work. The other thing about the launcher was the need to use different blocks. Needed other blocks to work.
Vocabulary!
Can we get a bet? So we pick a number between 1 and 1,000, and if you like do the random number generator, and if it lands on that number, we don't have to present.
We should do
Come
that.
on.
What number are you?
1 through 2. 1 through 2 would be 1.
1.
Oh,
No, let's actually do that thing. Come on.
2.
Move!
Ryan.
No, I'm on this. 3D printing by Mia Hands. Our technology was Tinkercad and a Dremel 3D slicer. And our launcher was Tinkercad sketching and designing prototypes.
Smart Goal. Our challenge is to come up with your own inventions or product ideas. Design a draft prototype with Tinkercad and evaluate your prototype. See if you can find ways to improve it based on what you discover through analyzing the design. Your design will include a circular logo. Our Smart Goal. We will use Tinkercad sketching and designing prototypes to create a custom Xbox Elite controller roller that I made through Tinkercad software. I will do this by designing a 3D object and sending it to a Dremel 3D printer. In these 4 days, I will be able to make an extra box controller roller that will take holder without any support to stand itself. It should be a 50% infill and it should be completely flexible. It will probably be 4.5 inches in height, 4.6 inches wide, and 3 inches deep. Attainable. We should know all the tools that Tinkercad has to offer, such as fold, copy, paste, rotate, how to scale things, and we should know how to calculate PI, or at least know how to find it. You need to know how to save your design to a flash drive, and how to actually start it when you need to get to that point. Relevant. I am doing this because I like to play my Xbox and I need a holder because right now they just sit on my floor and it's not organized. Well, on birthday one, the controller model I found online and I model my stand around that. On day 2, I will try to perfect it and or to the best of my ability and start different. On workday 1, we'll see if my model is successful, and if it isn't, I will rework it and make it work and print again. If it's successful the first time, I will still try and make it work better. On day 4, I will see if it remodeled version works, and if not, I will try again. If it does work, I will print something small or a teacher.
About our technology. Our technology is a software designed to make 3D models so that you can print them. It uses shapes that you can mold and model to your liking. You can design pretty much anything that is within the size and capability of your printer. The Dremel 3D Slicer is a tool that will show you how many grams your print will use, the quality you want it, and the quality you want it in. That is how little the printer can make each line of print. Also, the material you can use may be we used a PLA filament. It's a plastic that is super strong and lightweight. It comes in about every color imaginable. It is also super cheap for a roll, on average $15 per kilogram. And that's what the slicer looks like.
Relate your launcher to the real world. Tinkercad is used by tons of people that make 3D models, and it is also used by companies to print parts and other items. For really small items that a 3D printer could print fast, it could be really efficient to use a 3D printer instead of a cast with a molded plastic. Also, companies are starting to make 3D printed houses by using a concrete printer. These houses are super cheap. To make and with this current housing market, using this to print your house could be a good option. And people use 3D printing to make wall holders or stands that can hold things that otherwise you should have. That's a 3D printed house, and that's the 3D printed controller holder.
What problems did we have? Yeah, I had an issue with getting my controller to print right. The first 2 times I had problems with not in the filament, as it caused it to shift the print midway through, so it was all offset. I couldn't really do anything but print again, so that's what I did. I also had a big problem with my first design of the controller holder. I was originally going to make a big block with a hole that is in the shape of my controller, so I switched to a stand that the controller could rest on.
I had problems with getting the right size for my disc holder. Having all the parts be connected. The dividers I had the most problems with because the dividers wasn't all the way connected. So now one moves around, so I had super glue it, and it worked. I haven't tested it out, but it should fit my disc. I had problems with making the holders the right size. It wouldn't fit in the 3D printer, so I had to make it smaller. So it would fit, and after doing that, I got it so it would fit. And now after I got done with that, printing, it worked out perfectly.
Explore that. I can think of forming a toy car with shapes. You could use donuts as the wheels and a long oblong oval as the axle and a rectangle for the cab. I'm also thinking about making a controller for my Xbox using rectangles and other shapes. The function of the trash can is to read a shape, and the 3 pieces of paper is to paste, 2 pieces is to copy. The 2 triangles that are mirrored is the mirrored button, and the button with the gray and white lines to make a hole for your object. The images created are in a 3D form and they are used to be made into a real thing using a 3D printer. A 3D printer uses different materials at high temperatures and prints them to make a thing. This is a design of a controller holder that I found online. Day 1. Today I started working on my model for my Xbox controller holder. I'm using the Tinkercad software to design it. I found a model of the controller that we will be holding so that I can base my controller off of that. I put the model Xbox controller and I built my stand around it. It will be 6 inches tall and about 6 inches wide.
Today I got my model that I found online, and I imported it to Tinkercad so I can go off of that when I'm working on my disc. And I started that, I got the base and the front thing done, so now all I have to do is the dividers and the size for that, and then I'm done and I can print. That's my controller holder, or not my, that's my disc holder.
That's the Xbox controller that I modeled on.
Ah!
Day 2. Yesterday before school, I started my print for the Xbox controller holder. I learned that my model was built a millimeter off the ground, so that might have messed it up. My print was all shifted to one side, and it was lopsided, but I found that the model I made will work. I'm still questioning why it got messed up, but me and Ponzo came to the conclusion that there was a knot in the filament. I should have made sure that everything was in place and that there wasn't any imperfections that could have messed up my print. Tomorrow I will try and print again, and hopefully it goes smoothly and is made correctly.
Today I started off with getting all the dividers done so I could print at the end of class. I finished up all the dividers and I got it done with 10 minutes left, and I could hurry up and start printing. Eli helped set up the printer and filament, and then I printed it, and hopefully everything turns out good so I don't have to reprint it. But if something does go bad, I have another due day to print it again.
Day 3. I printed my controller holder again and modified it by making it a little bit shorter on the top so that I would use less materials. I changed the filament of 3D 45 from blue to a red color. The print will take 10 hours and I will use a 20% infill so that I use the least amount of material. I learned how to change the filament in the printer and how to copy the files from one USB drive to another. The model this time is 6 inches tall, 4 inches deep, and 5 inches wide.
It is the last due day, and I came to class and I figured out something got messed up when it was printing. So I had to reprint it. So I looked over it again and made sure that there was nothing wrong with it, so I could reprint it. Mr. Ponzo was gonna reprint it, when he found out that it got messed up. But the name, when I changed the name, it didn't save, and it was a weird name at first, so he didn't know what it was, so he couldn't reprint it. The first time I printed it, I was using clear filament, so I could have been the reason why it got messed up. I changed it to white, and then I reprinted it.
Today I started my print again because the last one got messed up. It got shifted on the shaft that holds the controller up. I helped Hans change the filament in the 3D20 from red to a whitish color. And I changed the filament in 3D45 from blue to red. This time I made the shaft a little bit skinnier so that there was less room for error. I'm still wondering how to center two things at once, but maybe I will find out how to do that. I also helped Hans glue his 3D design because one of the pieces is loose.
And today I got my 3D printed disc holder, and it came out good. So I painted it, the PS5 logo I put on the front of it so it's blue, so it looked a bit better. And some of the dividers were loose, so I super glued it and it worked perfect. But now it doesn't move inside the
Our final project illustration. Mine has two divots that are placed where the controller will sit in a backrest so that the controller won't fall over. It is 5 inches tall and 7 inches wide. The area of the base is about 35 inches.
And my disc holder has 10 slots, so it should fit, so it can hold 10 bits. My disc holder is 7 inches long and 5.5 inches wide. I made it so white because my PS5.
Conclusion. Yes, we achieved our SMART goal. We successfully finished our project within our time goal, and we made them how we wanted them with some minor modifications. We would do this again, but the things we would change is trying to make more complex designs and adding more details. We like how you could find a model of the thing you were trying to hold or model, and then you can design around that, and you know that your model will work. Our successes were that we finished the models and printed them. We completed the SMART goal, and became more familiar with Tinkercad and the Dremel slicer, and became more comfortable with 3D printing.
We learned how to the centerpiece on Tinkercad perfectly, and how to use the ruler. So you have even models and block plates, adhesion, and we worked well. We helped each other out when we needed such as changing filament and setting up the Dremel software. I learned that there is a tech shadow feature on PowerPoint.